Well, we were talking earlier about distance equals rate times time. And those are really fundamental parameters in spaceflight because if you're going to cover, let's say, some given distance, Earth to Mars or something like that, and you want to do it in a short amount of time, maybe you have some bioastronautics kind of constraints on the human's exposure to zero-G or radiation, then if you're trying to compress that time, then you need to up the rate to cover that distance. And if you up the rate, then you're going to involve increasing this delta V parameter that is of fundamental interest. And delta V, of course, is change in velocity. So if you can imagine yourself leaving the Earth's orbit for Mars, if you're going to use a really short trajectory, you're just going to go radially out from the Earth, radially out from the Sun to Mars. That's the shortest distance to Mars's orbit. But it involves a right-hand turn from the direction the Earth is heading around the Sun. And that's a huge delta V. You're going in this direction, you want to make this right-hand turn. You can imagine making a right-hand turn at almost 30 miles per second, the Earth's speed around the Sun. You're going to need some huge turning ability. And of course, that means propellant, and propellant being roughly proportional to delta V for a maneuver. And that means increased mass. And so there's this rocket equation that tends to really run away with mass when you have more and more propellant needs.